Hello learners, welcome back to Constant Learners. Today's topic is query processing. Stay tuned until the end and I can assure you that you will not have to memorize anything related to query processing. Let's begin. Now, the literal meaning of the word query is question, but in database management systems, its meaning is statements. The statements that we use to communicate with the databases are known as queries. Now, why do we need to communicate with the databases? See, we may need to create the databases, create the tables, select the data types. Then we need to insert the data inside the tables, modify the data inside the tables, alter the tables themselves, or we might need to delete the data or the tables, right? So for that we need to communicate with the databases, and to communicate with the databases we use queries. The process of extracting data from the database is known as query processing. Alright, the steps that the system, that is DBMS, goes through to process a request, that is to process a query. That means translating and executing a user query to generate the output is known as query processing. Alright, the entire process of query execution is known as query processing. Now, before understanding the steps of query processing, let's discuss some important points regarding the same. It is important for you to know these points because it will make the understanding of query processing very easy. We communicate in different languages. Let's say we are communicating in English right now, right? But we cannot use elaborate English sentences to talk to databases. Like, hey DBMS, can you please fetch the data of all the students who are in the CS department and have scored more than 75% marks? Thank you. That's not how it works, right? We need to communicate with the DBMS in a language that it can understand. It has to be on point, syntactically correct and precise, right? So, we communicate with the databases in a language known as structured query language. This structured query language is a high-level language. But DBMS cannot understand structured query language also. It needs to translate this language into a low-level expression that is in relational algebra. Right? Why can't it understand structured query language? Because structured query language is a declarative language. Declarative language, or we can say that it is a non-procedural language. Non-procedural language means what? It only tells the system what needs to be done and not how it's supposed to be done. Whereas relational algebra is a procedural language. Procedural language means what? It tells the system what needs to be done along with how it is supposed to be done. Right? Like in SQL, we write the query, select names from students where marks is equal to 75, right? But how are we going to select this data? That means how are we going to fetch this data from the database? That is not written in structured query language. However, in relational algebra, it explains this also. That is, how is the DBMS, how is the system supposed to fetch that data? We'll discuss that in a bit. Now, there are multiple ways to process a query. Why? Because relational algebra can have many equivalents that will fetch the same output. For example, if someone asks me, what do you do? My answer will be, I am a computer engineer, I'm working as a database administrator, and I have a passion for teaching. So, I teach in my free time, right? Or I could say, I am a computer engineer working as a database administrator with a passion for teaching. So both the answers are giving the same information, right? But One is said in a different way, the other one is said in a different way. Similarly, in case of relational algebra, there can be multiple different ways to fetch the same output, right? And this is very important. Why? Because from them, we can then choose the best way, the most efficient query execution plan to fetch the data or to generate the output. Which one will be the best, the most efficient query execution plan? The one that requires less time and least amount of resources. Right? I hope that this was clear. Now let's discuss the steps involved in query processing in detail. When a user writes a query, it is first received by the parser and translator. Three things happen in the parser. First is lexical analysis. Second is syntactical analysis. And the third one is semantical analysis. Now, in lexical analysis, the query is broken down into small meaningful parts known as tokens. What are tokens? What are these meaningful parts? Let's understand with the help of an example. We have a query, select names from students where marks are greater than or equal to 75, right? Now this query has a stream of characters, right? These are all characters. Select names from students where, etc. Right? And these are converted into meaningful tokens character by character. That is from left hand side to right hand side. One by one, these are converted into meaningful tokens. What tokens? Like select is a keyword. Then name is an identifier because it is the name of the column, right? So this is an identifier. Again, from is going to be a keyword. Students is the table name. This is also an identifier. Where will again be a keyword. Marks is again the name of the column. This will be an identifier. Now greater than, equal to, less than, greater than, these are operators. Correct? And 75 is the value. That means this is a literal. Okay? So like this, character by character, every word from the query is converted into meaningful parts known as tokens in lexical analysis. So these are all tokens. Keyword, identifier, these are tokens, right? Next comes syntactical analysis. What happens here is it checks whether the query follows the correct syntax rules or not. That is, the query is written correctly or not. Like, see, in the query we use the word select. Correct? Now, instead of select, if I use the word choose, both have the same meaning, right? Rather than select, I'm using choose. Is it going to be correct? No. So we are using wrong keyword, right? Invalid syntax. Like the query is written as select names from students. Rather than that, if I say select from students names, it's going to be wrong, right? That is entirely wrong syntax. Or if there's mismatched parenthesis. Parenthesis means what? The brackets. If first I've used a round bracket and after this I'm using a square bracket, then that will also be an error. Correct? So this is checked in the syntactical analysis. Next up is semantical analysis. In semantical analysis, the table names, column names are checked. That is, whether these tables, columns are available in the database or not. Then it checks the data type. Why data type? For example, in this query, select names from students when marks are greater than or equal to 75. Now, what if I write where marks are greater than or equal to A? Is it possible? Is it going to give me an answer? No, it's not going to give me an answer because A is a character and marks have been defined to only store integer values. This we define while creating the tables, while creating the columns. So this value cannot be accepted here, right? So this is an error. This is checking the data type, right? And this happens in semantic analysis, right? Also, it checks whether the query is making sense or not. For example, if I write a query, select names from students where department is equal to admin. Now this is not possible, right? This is a senseless query. It does not make any sense. There are no students working in the admin department, right? So this query does not make any sense. Now in case there's an error, the user is notified about it. If you've ever worked with the databases, you might have seen that when there's an error, it comes with the line number, that is, this line number has this error, or the table mentioned does not exist, or the database mentioned does not exist, like that. So the parser performs lexical analysis, syntactical analysis, and semantical analysis. Now the query is translated. Here there's a translator also. As we discussed, if there's an SQL query, it is converted to relational algebra, right? The high level query is converted into low level expression. How does this happen? Let's discuss that. Again, let's take the same example. Here we have select names from students where marks are greater than or equal to 75. Now the table mentioned here is the students table, right? So let's start with the table name, that is students. From the students table, what do we have to select? We have to select the names where marks are greater than or equal to 75. So we only need the students whose marks are greater than or equal to 75. So we start with select marks greater than or equal to 75, right? And do we need to project the entire data of the students whose marks are greater than or equal to 75? No, we only need to project the names, right? So we write project names for the students whose marks are greater than or equal to 75. So here, this relational algebraic expression tells the DBMS how we need to fetch the data. How is it saying that? First, it's informing that the data has to be fetched from the students table. Now, which students do we need to select whose marks are greater than or equal to 75? Once those students have been shortlisted, then we only need to project the names of such students, right? So this is how the query is converted into relational algebraic expressions, correct? Now the translator converts the query into relational algebraic expressions along with generating some trees and graphs. These trees and graphs also help in execution. Alright. Now, once the query, this relational algebraic expression has been given from the parser, it comes to the optimizer. In optimizer, some kinds of logics and rules are applied on the relational algebraic expressions and they are converted into data structures. These data structures are used to generate the evaluation plans. Why evaluation plans? Because in the previous slide we discussed that there are multiple ways in which we can fetch the data from the database, right? The relational algebraic expression can be written in multiple different ways, right? That means there are multiple different paths through which the data can be fetched. So these evaluation plans help us to generate the execution plans, right? These execution plans are the multiple paths that may be used to fetch the data. What do I mean is, let's say we are starting from here, right? So from here we can either go to this direction or this direction. Let's say we went in this direction. Now from here we can go to this direction. From here we can go to this direction. Probably from here also we could fetch the data, but this one would be the shorter path. That is why the DBMS will choose this path here, the shorter one that requires less time. right? And execution plans help us to generate these paths that helps the database management system to execute the query faster. Alright. Now, after all the paths and query plans are generated, it is time to choose the plan that is more efficient. And which one will be the more efficient one? The one that requires less time and less resources. And for that, the statistics about data is going to help the optimizer, right? It will inform the optimizer about the total number of rows that will be present in the output, the total number of distinct values in a column, the total null counts inside the table. It informs the optimizer about the indexes present in the table from which we have to generate the output, right? It will also tell the optimizer about the best join operation that can be used to perform that particular task, right? Or it may inform the optimizer about reordering the join operations. That means in which order the query must be executed. So all of that is studied with the help of statistics about data. Alright. Finally, when the best plan has been chosen, it is informed to the query execution section here, which fetches the data from the database and generates the desired output. So first, the query passing takes place and it is translated from high level to low level, that is SQL to relational algebra. Once the query has been passed, these tokens are then sent to the optimizer, right? And in the query optimization phase, the best and the most efficient query execution plan is generated. This query execution plan is given to the actual execution section where the actual execution takes place and the output is generated. Alright, so that was all about steps in query processing. We need to discuss the query optimization in detail, which will happen in the next video. We'll see if we can achieve 100% optimization or not. If yes, how? If not, then what needs to be done? Right? If you have any doubts, any queries, make sure to write them in the comment section below. Subscribe to the channel. If you like this video, give it a thumbs up, and thank you so much for watching.